This model will illustrate an example of self-excited vibration, which is very prevalent in real machinery. For instance, vibration of highway signs, the flutter of aircraft wings, the galloping of transmission lines. I've seen power lines, telephone lines on icy days when the lines are vibrating violently with almost no wind. Now, in this particular model, I don't know what the phenomenon is. There are several possibilities. One is von Karman vortex shedding, in which a smooth flow of air causes a train of vortices to peel off. However, if one studies aeroelasticity, the flutter of an aircraft wing can be quite violent without being considered a von Karman problem. The failure of the Tacoma Narrows Bridge probably was due to von Karman vortex shedding. In this case, we don't know. We're just going to look at it and enjoy it. This cylinder is made of balsa wood, and it's flat on the side nearest me and round on the other side. And I believe we got the inspiration for this from the Den Hartog vibration book that we used here about 40 years ago. It's a fairly classical example. Now, we're going to blow a little air across this with a small centrifugal fan. And not much will happen for a little while, but eventually it will begin to move. Now, one word picture that one can use in this is, well, we've got negative damping. Instead of positive damping, we have negative damping as the flow of air strikes the flat surface, and as this vibrates slightly from in the vertical plane, we change the lift and drag, which causes us to put energy into the system. It takes several minutes for it to develop full amplitude. One can see a similar effect on highway signs along I-35, in which the signs are bending torsionally. But that's about all this one does. Other examples of self-excited vibration are a brake drum squeal and chatter in machine tools, or many, many problems